Hi, I'm David Dickman. I'm a Director of Product Management here at Cloudera for the Cloudera Data Warehouse, and I'm here to talk to you about multifunction analytics in the hybrid cloud. The truth is out there. We know that the answers to our most burning business questions are in the data that we have in our systems. We also know it's in the data that's out in the cloud. It could be anywhere. But if we can bring all that data together, really explore it and understand it, we can provide better value and more insight to our business. Let's take a look at an example. This is one of my favorite examples. It's a major grocery store. This is a major USA-based grocery chain, but their key differentiator is that they're a USDA certified organic grocer. But they also want to maintain environmental friendliness. That's a key part of their business initiative. Now, their challenge comes from the fact that they've got over 44 different stores in about 10 different cities, but they're dealing with hundreds of highly perishable organic produce items that they need to keep track of. Now, the real trick is they need to make sure they put enough food on the shelf, because if they don't put it on the shelf, they can lose business to any one of their 5 major competitors. But if they put too much food out, that leads to their current $45 million in annual losses due to spoilage. That's also not very environmentally friendly. So what we want to focus on is, how do we get smarter about inventory management? So we put the right amount of food, but not too much, so we don't miss sales and we don't waste goods. So that's going to be a 2-step process. The first step is about exploration and discovery. This is the step where we're going to take a look and see, do we have all the data we need? Are we asking all the right questions? Let's build those queries and slice and dice and take a look. Do we have something that will actually impact our business? And in this case, are we asking the right questions whose answers will lead to a better business model? So once we know what those questions are and that those answers are meaningful, we get to step 2. Step 2 is all about delivering that in production. So this is where we're actually going to build the data ingest for any data that was not already in the system. We're going to make that a permanent part of the data flowing into our analytics system. And then we use data engineering to prepare that data and optimize it for our specific use case. And then we're going to optimize the schema to make sure that it's capable so that tens to hundreds of thousands of people can be accessing these news dashboards and reports in as close to real time as possible, so we can deliver these answers organization-wide. So let's take a close look at step 1, exploration and discovery. This is about the line of business analyst understanding what's going on and what new data could possibly help with the insight. So they want to ask 2 questions. Do I have all the right data? If not, where can I go get it? Can I look at it and see if it makes sense? And step 2, are the answers to these questions that I'm playing with going to help my business? So today's example, we're going to explore 2 potential hypotheses out of hundreds that we'll likely explore in a situation like this. The first is, will population density over time, will changes to city population density over time affect our sales? The second is weather and weather changes over time affecting our sales? Now, what's typically holding us back in a situation like this is, first, even finding the data. Where is it? How can I get into the environments that we have and the environments that are out there and see, is the data there? Is the data real and is it useful? And that can take a lot of time. But the second thing that holds us back is having the right resources available to us to slice and dice with schema and data. We're going to be running dangerous types of queries. Select star from megatable just to see what's going on. We don't want to be doing that in an environment that affects other running systems and affects KPI. So what we want to do is have our own resources. So we got to wait for those to be set up and made available for us. And even if we discover the data, if the data is not in our systems already, we have another wait state where we're waiting for that data to be loaded. And all of this really slows down that research and discovery time. But we're going to streamline that, because what we're offering is self-service exploratory analytics in the hybrid cloud. So let's begin by going into Cloudera Data Warehouse. We're going to be exploring an existing data warehouse and an existing data set that's on that data warehouse. We're going to use Hue. Hue is the Cloudera Data Platform's SQL editing tool. This is where we're going to slice and dice through schema and data. So here we already have the sales data loaded into our environment. Let's just do a quick drag and drop. Hue helps us create the query. Let's run that query and take a look at some of the sales data that we have. So as the query runs, here we go. We've got some sales data. This is looking pretty good to us, so we know we've got a basis for asking about sales correlations. But the next thing we want to do is look for population data. This is our first hypothesis. So I do another search in Hue. I can do tag search using Atlas. I can look directly at the tables and columns. I don't find anything that looks like population data. But never fear, I can use the importer. I'm going to import from a file on my hard drive. I have 3 years of census data that I downloaded into a CSV. Now when I bring this in, Hue detects whether there's a header row or not and makes the column names after the headers. We can also change the table name. By default, it's going to be named after the CSV, but that's not very meaningful to us. So we're going to change the name to a table name that we like. What we're also going to do is take a look at those column names. We can make some adjustments to those as well. And we can also look at the data types. We do a peek at the data with Hue, but we may not get that data type just right. So if you don't like the defaults that we pick, you can go ahead and change them. When we like what we see here, we can go ahead and hit submit. This will create the table, insert the data into the database, and give us a new table that we can now use in queries in Hue. So let's go back to the editor, go back to the Unified Analytics, and here's our new table. So let's go ahead and use Hue again, and let's take a look. Did we bring that data in? So we're going to drag and drop from Hue again to create that select limit 100 query for us. Get a little taste of the data and see if what we brought in looks like something that we're going to want to explore. And when we run this query, we see that, yes, successfully, from that CSV that was on my hard drive, we now have in our data warehouse and accessible to Hue the data that we have for the city population densities over time. Now, I'm going to create a correlation query. This is a standard correlation function. We're looking at the basic correlations, ups and downs of the two different data sets as they relate to each other. That comes out as a correlation coefficient. The closer to 0 this is, the less correlation we have. The closer to 1, the more of a strong, and the closer to -1, the more of an inverse strong correlation that we have. So here we see a bunch of numbers that come back that are really close to 0. So this is telling me, just from our little taste that we've taken, that the changes in city population over time have very little impact on the day-to-day sales that we have. So this is a hypothesis we don't want to explore any further. Now, in the interest of time, we're going to jump ahead. We've imported 3 months of weather data, and we're going to run a similar correlation query, but now focusing on weather changes over time. And when we run this query, we see in the result sets a much stronger set of numbers, some very close to 1 or -1, showing that yes, indeed, weather does have an impact. And that's what tells us very clearly that through slicing and dicing through these tests, which data sets we want to focus on for building new analytics and which data sets we can ignore. So this is great. Now we know weather has a direct impact on our sales on a day-to-day basis and can help us improve our inventory management. So what's next? We need to deliver those insights at scale. We've just done some tests on our local machine. We've done some tests with local data in the data warehouse that was our virtual warehouse that we built for our own slicing and dicing. Now we got to make it real. So to do that, we're going to involve the whole team. We're going to involve the ingest developer, and they're going to build that data stream for us for that weather data that's going to come in. Next, we're going to involve the data engineering folks. And they're going to prepare that data in an optimized way for our use in this particular use case. They're going to do the aggregations. They're going to bring in just the right columns. And that's going to deliver everything needed to the business intelligence folks. And what they're going to do is they're going to focus on optimizing that schema. They're going to be slicing and dicing through schema and data so they can understand how to make that the most performant warehouse so that when the business analyst gets involved, they're building out the dashboards and reports that will be used for up-to-the-minute weather forecast information to let us know what inventory to move out and what inventory to bring back. Now, what's typically holding us back here are the development times. Building those data streams and getting them to come in can be a long and arduous task. And preparing the data with data engineering can also add additional wait states where we have to dev, test, produce, deploy. And the BI development itself can also be, and we have to wait for these other stages. I need to wait for those tables to be there. I need to wait for that information to be there. So what we're going to offer with the Cloudera Data Platform is self-service everything. We're going to offer self-service data flow development. We're going to offer self-service data engineering. We're going to offer self-service data warehousing and self-service for business intelligence dashboarding and reporting. So let's take a look at that in action. So in this demo, we're going to start with the management console. Here we can explore the different environments, and we have an environment set up already where we're going to build everything for our end-to-end. Now let's start with the Stream Messaging Manager. This is where we're going to define the actual streams that will be bringing that weather data in. We're going to define two streams. We're going to create one Kafka topic that's going to be about the current weather. When we create this Kafka topic, we need to provide some details. We'll just take the defaults here, but we're going to create one for weather. We'll use the small sizing. And if you're interested, you can explore some of the more advanced settings here, where you can see even more details. We're going to accept all the defaults here. We don't need to play with anything here. But you see, you can get really into the controls on this one. Repeat this for weather forecasts. So what we're doing is we're bringing in current weather data, which is all the history that we're using to base the trends on. And then we're going to use those trends to inform us against the weather forecast on what we need to take action on right now. So we need both those weather streams. Now that they're built, what we don't have is the what. What is going to be carried across these Kafka topics? So to do that, we need to get into the schema editor. The schema editor is going to help us define exactly what's going into these Kafka topics. So we go to the schema editor, we find that there's nothing there. That's fine. We're going to create a new one. I'm going to create a weather current one. We'll give it a meaningful description. We'll determine what type it is. And basically what we're doing here is defining the structure that's going to be in the data flow. When we're done with these definitions, you can see a quick peek here at the code that we're automatically creating for this Kafka topic. And we will simply save this. We'll repeat this again for the weather forecast. Do that nice and quick here. And now that that's done, we need to deploy these to our environment. So to do that, we're going to go to Cloudera Dataflow. So the first step we're going to do in Dataflow is we're going to bring in those Kafka topics that we just created. We see here there's a library of them, but we want to import the ones that we just built. So go ahead and import these to into the weather data. We're going to import both Kafka topics into the same flow definition. We'll still have to define the details of them as we move forward. So now that we have these here, we'll deploy these to our environment. And these deployments ensure that in that environment where we're creating these, we're going to be able to do data engineering on that. We're going to be able to do data warehousing on that. So it's important to put it into the same environment. Here we'll set the flow parameters. We need user, password, various other parameters that we can set. And once that's done, again, we'll bump up the sizing a little bit here. We can pick which node size we want. We'll repeat this same process for both the past weather data and the forecast weather data. Next, we can go into the ready flow gallery where we can use ready-made flow definitions. What we ultimately want to do is bring in that data from the JSON file and have it ultimately end up as an S3 file that we can use in other places. So we're going to use the Kafka to S3 Avro. What this is going to make is an Avro file in the S3 bucket that's going to be visible to data engineering and data warehousing. We're going to do a deployment on these. Again, we need the users and passwords. We need to set a number of parameters. But again, we're going from that JSON. We're going to go into the S3, going to go in as an Avro file. And we'll ultimately create this topic. And I'm going to repeat this. I'm going to do this twice. Once for the current weather and once again for the forecast. So again, we're doing this for the forecast. All the same things we did before. Same parameters, JSON, ending in an Avro file in S3. And here is where we actually define. We're defining that actual S3 bucket that we're going to be putting this information into. And then we deploy these out to the environment. So now here we see that some data is starting to flow. We see the reads and writes are happening. So this is a nice, healthy data flow. So now that we have a data flow coming in, we need to prepare that for use in the data warehouse. So to do that, we're going to go into Cloudera Data Engineering. Here we have a couple of CDE services. We've prepared this service already for use. And we'll go ahead and create the Spark job. Now, in the interest of time, you could create the Spark job right here, but we're just going to bring it in from a jar file. We've already built the Spark job in advance. And we're going to go ahead and prepare that job. Now, what's interesting about the job is we can set the various parameters to it. But once we've set those parameters, one of the other things that's interesting is setting up the scheduling for this. So we want to run this job to bring in new weather data. We're going to run it. We're going to set it to run once an hour. We're going to set it to run on the 30 minutes past the hour. And we have a start date and an end date. We can set those, so we can set a range so that it will run over a certain range of time and then stop, or it can continue to run. And when we're done, we'll hit the schedule button. And that will set this up to be executed in our environment and start loading those Avro files with the data defined by the Spark job, which includes the aggregation and all the other work that we do to properly prepare that data for use. So now that that's done, we see that the job is there. But what's interesting is, we set it to run on a schedule. So instead of waiting 30 minutes for this to run, let's go ahead and run now. What this is going to do is this is going to execute the job right now as we're sitting here. Now, let's go see what's going on. To do that, let's go to the job runs and take a look at the job that's actually running here. Let's drill into it, and we can see this job is actually starting up. On the left, you see that little spinner that's going to become a green dot when it's done running. And here we go. It's done. And if you really want, we can peek further and look at what actually happened in the job by taking a look at the logs. So here we see everything that happened by that Spark job running. So if you really want to get under the covers and see everything that's going on, you can do so right here in the console where you've defined everything. So this is great. Now what we've done is we've got that data flow running all the way through into an Avro file, into something that's prepared, and data is loaded. So let's go to the data warehouse. Go back to Hue, our SQL editor, and let's take a look at what's going on with that data. So here we see we have the weather data. So let's take a look and see, did we get any actual rows of data from running that job? We run the query, and there we go. We have rows. So here we can now optimize that table. We can get everything ready to build those queries that we'll use in our analytics. But let's jump ahead to the analytics itself. Now we're in Cloudera Data Visualization. Let's take a look at this dashboard that we've built. This is an existing dashboard we've augmented with the weather data. So we see the sales data, but you see we've added lowest temperature, highest temperature, some nice little high level details here. But we also have our existing sales data. So we see our store distribution pie chart. We see our sales by store here. We see what's going on in all of the different stores by product. And this is our typical sales data. But what's really fun is what we've added to the bottom of this chart. This is where we get directly into the weather correlation information. And this is where we really get to use that. So let's zoom in on that a little bit. And what we see here is wherever there's a dark green, that's a strong positive correlation. A light green is a weak positive correlation. Dark red is a strong negative correlation. So as we read this, if we look and we see on a given day in New York, we want to increase the amount of certain products that we're selling by a lot or a little based on a dark or light green. We want to remove and put on ice certain products. And really interesting is if you look across San Francisco, you'll see that there really isn't a whole lot going on there. And that's because as we dig deeper, we discover San Francisco specifically has very little variance in weather, let alone sales. So this way we see that right down to the specific product in the specific city at the specific store, we can make an up to the 30-minute mark decision on what to move back and what to bring forward to make sure we give the right products to the right people without missing a beat. So in that demo, we saw how the Cloudera Data Platform was able to get us very quickly from exploration to insight and putting that into the hands of the people who need it most. But what Cloudera Data Platform gives us is out of the box and ready to go. Ready to go exploratory analytics with self-service exploratory analytics, getting us those answers to those burning questions quickly. And from there, we have ready to go rapid development, getting us those insights into the hands that need it most in a productive way as quickly as possible. And finally, we have ready to go business insight with blazing fast turnaround and immediate satisfaction to get you measurable results. So what did that do for our use case? Well, first with exploratory, we were very quickly able to hone in on the fact that weather data was the important factor. And then in a matter of weeks, not months or years, we're able to deliver the solution with a weather-driven dashboard that managers can take effective use of, which gave us the benefit of an immediate reduction in waste and a total savings of over $40 million a year in lost inventory. So that's how Cloudera Data Platform in the hybrid cloud can bring new data insight quickly to your business and make an impact. Thank you.